Now the next application is electric field at an outside point due to a charged sphere. Okay, so let us have a charged sphere of radius capital R and the total charge is Q. So from the center of the sphere, let us take a point here P, suppose at a distance small r, and obviously small r is greater than capital R, and we want to find out electric field here applying Gauss law. So therefore what we have to do, the first thing we have to do, if you want to apply Gauss law, we have to enclose the charge. So if you want to enclose the charge, taking this smaller as a radius, first of all let us assume an imaginary sphere that will enclose the charge. So if you enclose the charge, if you apply Gauss law, integration of E dot ds will be equal to Q net by epsilon 0, and integration of E dot ds also can be written as E ds cos theta, that is equal to Q net by epsilon 0. So now see, if you take any surface on this imaginary sphere, suppose if you take a surface ds here, so the ds will be in this direction, and as the charges are on the surface, so electric field also perpendicular to the charge. So electric field is perpendicular to the charge, ds is perpendicular to the surface, so both are in the same direction, so therefore theta will be 0. So if theta is 0, cos 0 will be 1. So therefore we can write here, it will be only EDS, that is equal to Q net by epsilon 0, as theta is 0, or E parallel to ds you can write. So therefore what we can do, E is taken out of the integration. So therefore E into, now integration of ds over the entire surface, it's a sphere, mind that, again I am saying it is a sphere, it is not a circle, it is a sphere enclosing the entire sphere. So the total surface area will be 4 pi r square. 4 pi r square, that is equal to, now Q net you can write Q because the total charge is Q, so it is Q by epsilon 0. So therefore E can be written as equal to Q by 4 pi epsilon naught, this is going to downward, into r square. So this is the electric field, expression of the electric field. Now one thing you can do, the special case, that is if small r is equal to capital R. Small r is equal to capital R means what? Small r equal to capital R means if the point is not here, but if the point comes here on the surface of the charge sphere. Okay, this is a special case. If the point is on the surface of the charge sphere or very close to the surface of the charge sphere, both. Okay, on the surface or very close. So therefore, what we can do, if you take this equation, you can write E will be equal to Q by 4 pi epsilon naught capital R square, small r equal to capital R. Okay, so now here you can use a concept of sigma. Sigma is what? That is the charge per unit area, charge per unit area. That means sigma can be written as equal to Q by, what is the total area? Actual area of the charge surface. Actual area is 4 pi r square, 4 pi capital R square. Okay, because the charge is actually situated on this capital R. So the total area will be 4 pi capital R square. So therefore Q can be replaced by sigma into 4 pi capital R square. So if you put it here, that is sigma into 4 pi capital R square by 4 pi epsilon naught capital R square. 4 pi r square, 4 pi r square goes on. So it will be E is equal to sigma by epsilon 0. This is another special case.